Looking to make your holiday gifts more extraordinary? There's one place you need to go, PaperSource. PaperSource's gift wrap collection includes hand-illustrated designs, stone paper, sustainable handmade fine papers, and even pine-scented wrap. Don't want to do any wrapping? PaperSource has easy solutions with their pre-wrap gift boxes and bags. Or you can leave it to the professionals with their in-store wrapping service. Give yourself time back and wrap up your holidays with something extraordinary. Visit papersource.com or stop by a PaperSource near you today.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 23, Episode 28, for broadcast on the 3rd of April, 2020. Coming up on SpaceTime, Jupiter's iconic Great Red Spot continuing to shrink. A new study confirms that Earth's rotation is continuing to slow down. And a new comet is getting really bright really quickly. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has confirmed that Jupiter's iconic Great Red Spot is continuing to shrink. The gas giant is the solar system's largest planet, with more mass than combined in the rest of the solar system other than the Sun. Its spectacular beige, salmon and brown swirling cloud tops are shaped by jet streams, winds and vortices into numerous parallel bands and coloured cyclonic patches, one of which, the Great Red Spot, clearly stands out from the rest. This Earth-sized anticyclone has been a feature of the Jovian skies for more than 350 years, ever since telescopes were first pointed at the heavens. But the Great Red Spot has been dramatically decreasing in size over recent years. Back in the late 1800s, the Great Red Spot was estimated to be around 41,000 kilometres wide, big enough for the Earth to fit inside it 3 times. In 1979, NASA's twin Voyager missions on their grand tour of the outer solar system flew past the gas giant, measuring the Great Red Spot at a still respectable 23,300 kilometres wide. But the vortex has continued to shrink, with the Hubble Space Telescope image taken in 1995 measuring it at 21,000 kilometres across. And by 2009, it had shrunk to a diameter of just 18,000 kilometres. Observations in 2012 revealed a noticeable increase in the rate at which the spot was shrinking, now by some 933 kilometres per year, and it was also changing its shape from an oval into a circle. The most recent measurements show that its rate of shrinkage has slowed down, but it is still getting smaller. It's now under 16,500 kilometres across, and it's also changed colour from a deep red into a pale orange. The cloud layer is extremely opaque, making it hard to observe what's happening deeper down. Now, using a combination of new laboratory experiments and computer simulations, scientists with the University of Central Marseille have been studying the dynamics of large vortices, providing a better understanding of how they're formed and structured. Now, based on their studies, they've concluded that despite its reduction in surface area, the thickness of the Great Red Spot has remained remarkably constant over time. The findings, reported in the journal Nature Physics, will now be compared to new observations of the Great Red Spot to be undertaken by NASA's Juno spacecraft during its next flyby of the gas giant. This is SpaceTime. Still to come, new evidence that Earth's days are getting longer, and a new comet getting really bright really quickly. All that and more coming up on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated #1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
So, how long is a day on Earth? Well, actually, that depends on how you measure it. Most people think of what is technically called a solar day, the length of time it takes for the Earth to rotate on its axis so that the Sun appears in exactly the same position in the sky. That's roughly 24 hours. Although it actually varies due to the eccentricity of Earth's orbit, the obliquity of the planet's axial tilt in relation to the ecliptic, and geological events occurring deep inside the planet, all of which can add or subtract several milliseconds. Another way to measure Earth's day, the way astronomers do, is by looking at its sidereal day, which is the amount of time it takes the Earth to rotate an exact 360 degrees on its axis with respect to fixed stars in the sky, which turns out to be around 23 hours, 56 minutes and 4.091 seconds, which is about 4 minutes shorter than the solar day. The difference is that as the Earth completes a full 360-degree rotation around its axis in a sidereal day, it's also moved a degree along its orbit around the Sun. So, to return the Sun to the same position in the sky it was the previous day means the Earth has actually rotated 361 degrees in a solar day. Adding to all this is the fact that Earth's rotation is slowing down. Back during the reign of the dinosaurs 70 million years ago in the late Cretaceous, a day on Earth only lasted 23.5 hours. That meant that an Earth year back then lasted 372 days instead of today's 365.25. The slowdown is due to gravitational tidal interactions between the Earth and the Moon. Scientists have known about these for years. Now, a new study reported in the journal Paleoceanography and Paleoclimatology has used fossil mollusk shells to provide a new way of confirming this fact. The ancient bivalve mollusk is from an extinct and widely diverse group known as rudous clams, which grew fast, laying down daily growth rings. The new study used highly precise lasers to sample minute slices of the shell and count the growth rings more accurately than human researchers with microscopes. This incredibly precise counting of the growth rings allowed the authors to determine the exact number of days in a year and more accurately calculate the length of a day 70 million years ago. The findings also add to science's understanding of how the Moon formed and how close it's been to Earth over the 4.5 billion year history of the Earth-Moon system. The authors' careful count of the number of daily layers found 372 for each yearly interval. Now, that's not a surprise, as scientists already knew days were a lot shorter in the past. However, the result is the most accurate now available for the late Cretaceous. The length of a year has been constant over Earth's history. That's because Earth's orbit around the Sun doesn't change. But the number of days in a year has been shortening over time because the days are growing longer. The length of a day has been growing steadily longer as friction from ocean tides caused by the Moon's gravity slows Earth's rotation. And the pull of the tides accelerates the Moon a little in its orbit, so as the Earth's spin slows, the Moon moves further away. In fact, the Moon's pulling away from the Earth at a rate of roughly 3.82 centimeters per year. That's about the same speed at which fingernails and hair grow. Precise laser measurements of the distance between the Earth and the Moon have demonstrated this increasing distance ever since the Apollo program left helpful retroreflectors on the lunar surface. But the thing is, scientists have concluded that the Moon could not have been receding at its current rate throughout its history, because by projecting its progress literally backwards in time at that rate would mean the Moon was inside the Earth just 1.4 billion years ago, and that clearly wasn't the case. See, scientists know from other evidence that the Moon's been with us ever since it was created out of a massive planetary collision between the early proto-Earth and a Mars-sized planet called Theia some 4.5 billion years ago. That impact turned both the proto-Earth and Theia into a magma ocean, while at the same time flinging debris ejecta into orbit, which eventually coalesced to form the Moon. So this means the Moon's rate of retreat has changed over time, which has affected the length of an Earth day. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
A chunk of rock that has been buried in ground for millions of years has become a new clock. This is an ancient fossil from the Cretaceous period that they're talking about, and it's shown up one interesting aspect of the world from 70,000 or 70 million years ago, I should say. The days were much shorter than they are now.
We sort of knew that theoretically because the day length is increasing as we speak, which is why we have leap seconds occasionally.
Yes.
And a lot of that is tied up with the interaction between the Earth and the Moon. The fact that the Moon's drifting away is because it's taking energy from the Earth's rotation, and that's slowing the rotation down. So we do know that process is ongoing. But this, I absolutely agree with you, Andrew. It is a beautiful piece of work, is this? And it's such a nice conclusion that's drawn. And, well, we've got a fossil of a shell, a bivalve shell. I think these things were probably quite a lot bigger than the molluscs that we're used to today.
I used to have one as a pet, Fred.
A pet bivalve?
Yes, in my fish tank.
In your fish tank? What was it called?
Fred. I'm not joking.
There you go. What a prescient name to give to your bivalve.
Yeah, he was great. He lived under the gravel and just, cleaned up. It was all right.
Yeah. I once had a cactus called Plug. It actually belonged to a friend of mine, and he bequeathed it to me. And Plug lived on the kitchen windowsill for many, many years. Anyway, that's another story. What's the story with the bivalve? They're shaped a bit like a vase, or a vase if you're on the other side of the Pacific. At the wider end, they've got this lid, and they were basically on ancient reefs. This particular species, I'm going to attempt its name, Toriites sanchezi. Anyway, the Cretaceous Paleogene or Paleogenic extinction. This is a time basically when the dinosaurs were wiped out. This particular species was also wiped out. They're now extinct. They don't exist anymore, but they are of interest because we have bivalves in the modern era. Probably nothing quite as big as this. But the really interesting aspect of this bivalve, this is common to the ones we see around us today, they have a growth rate in their shells which is 1 layer per day. And that's the key to this research, because it grows 1 layer per day, just like essentially, in the same way as tree rings put on a new ring every year.
Yeah.
But these things have 1 layer per day. So you can almost count the days when you look at the age of them. The key thing, though, is that they also respond to changes in the season. An example from modern day bivalves, a modern clam, one of those big clam shells. Yeah. In winter time, the layers that they put on are darker. And so the same is true of the T. sansegi fossil, that it had colour gradations in its, not tree rings, but in its layers of growth. So not only do you have a layer for each day, you've got a kind of marker for when the year changes, for the seasonal changes. And that is the crucial...
The smoking mollusc.
Smoking gun, that's right. So first of all, the team that analysed this, the team that did this work, basically, they're actually, I think the main geochemist who's involved with this is at a university in Brussels, in Belgium, just to give them a shout as well as to where they are. But they used these various layers to determine that this thing lived for an age of about 9 years.
Yeah.
Which is good. So that means they've got 9 years worth of information, and they've got the daily layers packed into that. And the key thing is that they got the daily layers fit into a year with not 365 of them, but 372.
Ooh.
So
hello.
That means there are 372 days in a year about 70 million years ago, which is this fossil.
So how long was a day?
It brings it down to about 23 and a half hours.
Good
so
grief.
you lose, if you do the calculation, 365 to 372.
So if you go further back, are they suggesting the days were even shorter and the years were many more?
That's right. So this is a really nice snapshot of what things were like 70 million years ago when this fossil was laid down. And you can sort of extrapolate back for the whole 4.6 billion years of the Earth's history. But you come to a time when it looks as though the day basically was very, very short. The best thinking on this, which comes about from arguments to do with the rotational energy of the Earth and Moon system, suggests that the fastest the Earth ever rotated, and this was probably not long after the moon was formed, was about once in 4 hours.
Wow.
So a day length of 4 hours.
That's when it got hit by Thea.
It's probably after it was hit by Thea,
Yeah.
because that's sort of extrapolating back from where we are now. This interests me as well from a historical point of view, because there was a scientist by the name of George Darwin. Has got a very famous surname because he had a very famous father. George is the son of Charles. Charles worked on the origin of species. George worked on the origin of the moon. He was an astronomer actually in Cambridge. And in the 1880s, I think it was, he developed this theory that very early in the Earth's history, the Earth had been spinning so fast that debris had spun off its equator. And that was what formed the moon. But
That's a good theory.
It is a good theory, yeah. But the reason why it got knocked on the head is that to do that, if I remember rightly, the figures are that the Earth would have to turn once every 2 hours. And the evidence seems to be that it never turned that quickly. I'm not sure what that evidence is. I think it might be dynamical rather than geological. But the thinking is that the Earth could never have rotated quickly enough for that to happen. And that's why we now have the Thea impact theory, as you just mentioned. But that's not really anything to do with this work. But this bivalve study, though, is really giving you a very nice pointer, just a little measurement of one period in the Earth's history when we can see without any question at all that the day was shorter and actually measure that. And I think that's an astonishing thing to be able to do. There was nobody around with a clock 70 million years ago when this thing was living on its reef.
No, indeed. And I suppose over the course of time, the rotation slowed, the days have become longer. And so here we are.
Here we are. But the other thing, of course, is that the moon has drifted away. The moon would have been much, much closer in the early history of the Earth-Moon system. Probably, it's one of the calculations, I'm sure it's been done, but I haven't looked at it. You could work out how far away the moon was 70 million years ago when this bivalve was alive.
So if you were to study a bivalve today, you'd find 365 rings per year.
That is what you'd expect, exactly. Because you get a daily laying down of a ring or a leg of the shell.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. Still to come, a new comet getting really bright really quickly, and our nearest neighbouring star system, Alpha Centauri and the Southern Cross constellation, are among the highlights of the April night skies on SkyWatch. All that and more still to come on SpaceTime. A new comet first discovered in the closing days of 2019 looks like it could put on a spectacular celestial light show over the next few months. Comet C2019 Y4 Atlas has been getting really bright really quickly. Atlas was discovered at a distance of 439 million kilometres from the Sun in the constellation Ursa Major on December the 28th. It was detected by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, after which it's named. The robotic survey system based in Hawaii is designed to search the skies for near-Earth objects on their closest approach. At the time of its detection, Comet Atlas was an extremely faint magnitude 20, some 398,000 times dimmer than stars visible with the unaided eye. However, as it's moved closer to the Sun, solar radiation has caused volatiles to degas, turning it into a spectacular bright green magnitude plus 8.5, more than 600 times brighter than predicted. Atlas will reach perihelion, its closest orbital position to the Sun, on May 31st, when it will swing around the Sun at a distance of just 37.8 million kilometres. That should be enough to increase its brightness by 11 magnitudes, potentially turning Atlas into a spectacular celestial light show, easily visible in a small backyard telescope or with a pair of binoculars. We'll keep you informed. This is Space Time. And time now to check out the night skies of April on SkyWatch. April's the 4th month of the year in the Gregorian calendar and the 5th in the early Julian calendar. The Romans gave this month the Latin name Aprilis. Although the name's origins aren't certain, traditional etymology suggests that it's from the verb apria, to open, as in it being the season when trees and flowers began to open as the Northern Hemisphere moves into spring. High in the southern skies in April is the constellation Southern Cross and its two pointer stars Alpha and Beta Centauri. The more distant of the two pointers is Alpha Centauri, the nearest star system to our own. Located some 4.3 light-years away, Alpha Centauri actually consists of 3 stars, Alpha Centauri A and B, which orbit each other, and Proxima Centauri, sometimes called Alpha Centauri C, which orbits the pair, and at 4.25 light-years distant, is currently the closest star to the Earth other than the Sun. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Like the Sun, Alpha Centauri A is a spectral type G yellow dwarf star. It has about 1.1 times the Sun's mass and just over 1.5 times its luminosity. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. That's followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun is, spectral type K orange stars, and the coolest and least massive stars are known as spectral type M red stars. Each spectral classification is then subdivided into a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and then a Roman numeral to represent luminosity. So, putting all that together, our Sun becomes a G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red stars or red dwarfs, but became brown dwarfs after losing some of their mass. Brown dwarfs are really interesting. They fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smaller spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or roughly 0.08 solar masses. Getting back to Alpha Centauri, the other star in the primary binary system is Alpha Centauri B, a spectral type K orange dwarf star, a little smaller and cooler than the Sun, with about 0.9 times the Sun's mass and about half its luminosity. Alpha Centauri A and B orbit each other around a common centre of gravity every 79.91 Earth years. The distance between them varies from about that between Pluto and the Sun to that of Saturn and the Sun. The third star in the system, Proxima Centauri, is a spectral type M red dwarf star, with about 1/7 the diameter and about 1/8 the mass of the Sun. It takes some 550,000 years to orbit Alpha Centauri A and B. The nearer of the 2 pointer stars to the Southern Cross is Beta Centauri, also a triple star system, but located a far more distant 390 light-years away. All 3 are young massive blue stars, far bigger and more luminous than the Sun. 2 of the stars, named Beta Centauri AA and AB, orbit each other, while the third, Beta Centauri B, orbits the pair every 1500 Earth years. Beta Centauri AA and AB are a spectroscopic binary, orbiting each other every 357 Earth days. Spectroscopic binaries are double star systems orbiting each other so closely and at such an angle that they can only be visually separated from our viewpoint on Earth by their spectroscopic signatures. Both are now nearing the ends of their time on the main sequence, and will soon run out of hydrogen for core nuclear fusion. Alpha and Beta Centauri are named after Chiron the centaur, a mythical Greek being who was half man and half horse. Chiron is said to have taught many of the Greek gods and heroes, but was placed among the stars after accidentally being shot with a poisoned arrow by Hercules. Next to the pointer stars is the magnificent constellation, the Southern Cross, or Crux. It's actually the smallest but one of the best known of the 88 constellations in the sky. The Southern Cross is at its highest point in the southern sky this time of year, and is pointing directly at the south celestial pole. During April, the Southern Cross lies on its side in the early evening, but becomes more and more upright as the night progresses. The bottom and brightest star in the cross is Alpha Crux, or A Crux, which is actually a multiple star system located 321 light-years away. It consists of 3 stars, A1 Crucis, which is a spectroscopic binary, and A2 Crucis. A2 Crucis and the primary star in A1 Crucis are both spectral type B blue stars, with surface temperatures of 26 and 28,000 Kelvin respectively. The 2 components orbit each other every 1500 Earth years, at an average distance of about 430 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, roughly 150 million kilometres or 8.3 light minutes. The two stars in A1 Crucis are thought to be about 10 and 14 times the mass of the Sun. The pair orbit each other every 76 Earth days at a distance of about 150 million kilometres, 1 astronomical unit. The masses of A2 Crucis and the larger component of A1 Crucis are expected to eventually explode as core collapse supernovae, ending up as neutron stars, while the smaller component of A1 Crucis should survive as a white dwarf. The left-hand and second brightest star in the Southern Cross is Beta Crucis. It's also a spectroscopic binary consisting of two stars. They orbit each other every 5 Earth years at an average distance which varies between 5.4 and 12 astronomical units. Beta Crucis is located about 280 light-years away. The primary star, Beta Crucis A, is a spectral type B beta Cepheid variable blue star, which changes in brightness over a period of 4 to 4.6 hours. It has about 16 times the Sun's mass and about 8 times its diameter, with a surface temperature of around 27,000 Kelvin. The second star in the system, Beta Crucis B, is about 10 solar masses, while a third companion has also been detected in the system. Near Beta Crucis is the spectacular young open star cluster known as the Kappa Crucis cluster NGC 4755, and more commonly called the Jewel Box, a name given to it by the famous 18th century astronomer John Herschel. Open star clusters are groups of stars which were originally all born at the same time in the same collapsing molecular gas and dust cloud. Although somewhat still gravitationally bound, it's thought stars in open clusters could eventually separate and move to other parts of the galaxy. As the name suggests, the Jewel Box is a stunning collection of more than 100 bright, colourful stars. It's located some 6,440 light-years away, although its exact distance is difficult to determine because of the nearby Coalsack Nebula, which obscures some of the light. The Coalsack is a dark nebula containing lots of gas and dust blocking out background stars. In Australian Aboriginal Dreamtime legend, the Coalsack formed the head of the Emu constellation, with the dark dust lanes of the Milky Way forming the emu's body and legs. The central parts of the Jewel Box are framed by bright stars, making up an A-shaped asterism. These are among the brightest known blue, white and red supergiants in the Milky Way. Truly a spectacular sight worth looking at. Gamma Crucis, which is located at the top of the Southern Cross, is the third brightest star in the constellation. It's also one of the nearest red giants to our solar system, located just 88.6 light-years away. Visually, it's also the nearest star to the two pointer stars. Although only 30% more massive than the Sun, its expanded outer envelope has bloated out to some 84 times the Sun's radius, and it's now radiating some 1,500 times the luminosity of the Sun. As a red giant no longer on the main sequence, Gamma Crucis is nearing the end of its life. Its surface temperature is 3,626 Kelvin, and it has a prominent reddish-orange appearance. The star on the right-hand side of the Southern Cross is Delta Crucis, a massive, hot and rapidly rotating star that's now in the process of evolving into a red giant, and will eventually end up as a white dwarf. The star's located 345 light-years away, and has about 9 times the Sun's mass and 8 times its radius. It's presently radiating around 10,000 times the luminosity of the Sun from its outer atmosphere at an effective temperature of 22,570 Kelvin, causing it to glow with a blue-white hue. The smallest star in the Southern Cross is Epsilon Crucis, which is located in the space between Delta and Alpha Crucis. It's another red giant, some 228 light-years away. It has about 1.42 times the Sun's mass and some 32 times its radius. Its surface temperature of 4,148 Kelvin means it's sometimes referred to as an orange giant. The Southern Cross is located within the constellation Centaurus the Centaur, which, as we mentioned earlier, is a half-man, half-horse in Greek mythology. The creature is holding a bow loaded with an arrow. The Centaur's front legs are marked by the two pointer stars Alpha and Beta Centaurus. His back then arches over the Southern Cross, and just above this is Omega Centauri, a spectacular globular cluster visible to the unaided eye from dark locations. Globular clusters are tightly packed spheres containing thousands to millions of stars, which were all originally born at the same time in the same molecular gas and dust cloud. Omega Centauri is about 16,000 light-years away. It's one of the largest and brightest of the 150 or so globular clusters known to orbit around the Milky Way. Centaurus was included among the 48 constellations listed by the 2nd century astronomer Ptolemy, and it remains one of the 88 modern-day constellations. The constellation Orion the Hunter is still clearly visible in the northwestern night skies, with its rectangle of 4 stars surrounding a central trio of stars which form Orion's belt. To the right or east of Orion is the constellation Gemini and its 2 brightest stars, Pollux and Castor. This time of the year, the Gemini twins are almost directly due north for southern hemisphere sky watchers. The higher of the 2 stars, Pollux, is a red giant, some 11 times the diameter of the Sun and located just 34 light-years away. The other star, Castor, is much further away, 51 light-years. Now let's turn to the east, and there you'll see the star Regulus, the brightest star in the constellation of Leo the Lion. Regulus, which means Little King, is located about 77 light-years away, and is about 3.5 times as massive as the Sun and about 140 times as luminous. Regulus is a binary companion star which takes some 130,000 years to orbit the primary. To the right of Regulus, and visually due east in the sky, is the star Spica. Located directly below the 4 stars in the constellation Corvus the Crow, it's the brightest star in the constellation Virgo. Spica, also known as Alpha Virginis, is the 16th brightest star in the night sky, and is another spectroscopic binary comprising 2 extremely close stars orbiting each other every 4 days. In fact, the 2 stars in Spica are so close together, their gravitational interaction has caused them to become rotating ellipsoidal variables, distorting them into the shape of a rugby league or gridiron football. Light from the binary changes in brightness as the 2 stars orbit each other, exposing their elongated hemispheres to us. Spica is located some 260 light-years away and is some 2,000 times as luminous as the Sun. By the way, the word Spica, well, it means ear of wheat, which, according to Greek mythology, Virgo is holding in her hand. It's so named because it marks the start of the harvest season in the Northern Hemisphere. The primary star in Spica is a blue giant variable beta Cepheid star, which undergoes small rapid variations in brightness because of pulsations of the star's surface. These are thought to be caused by the unusual properties of iron at temperatures of 200,000 degrees Celsius in the stellar interior. The star has about 10 times the Sun's mass and about 7.5 times its diameter. Once a spectrotype B main sequence blue-white star, it's now some 12,100 times the Sun's luminosity. The giant star is now pulsating rapidly and rotating at over 199 kilometers per second over a 0.1738 Earth-day period. It's also one of the nearest stars to Earth expected to end its life as a core collapse Type II supernova. The second star is also thought to be a spectrotype E blue-white giant, about 7 solar masses and 3.6 times the Sun's diameter. Now, going back to the Southern Cross and to the right or west of the Cross, you'll see the star Canopus, the second brightest star in the night sky after Sirius. Even though Canopus is 312 light-years away, it looks so incredibly bright because it really is huge. A spectrotype A white star, 100 times the diameter of the Sun and 10,000 times as luminous. Next we come to the constellation Carina, which together with 2 other constellations, Vela the Sails and Pappus the Stern, were originally part of a super constellation called Argo Navis, or the ship Argo, which was divided into 3 in the 1930s when the International Astronomical Union defined 88 official constellations. One of the most spectacular sights in Argo Navis is the Great Nebula in Carina, a massive cloud of gas and dust between 6.5 and 10,000 light-years away. It surrounds the truly massive Eta Carina binary star system, itself located some 7,500 light-years away. The 2 stars in Eta Carina are classified as highly luminous spectral type O blue hypergiants. The primary star is estimated to be around 150 to 200 times the mass of the Sun, with some 5 million times the Sun's luminosity, 800 times its radius, and a surface temperature of somewhere up to 32,500 Kelvin. The binary companion star, although smaller than the primary at just 80 solar masses and 20 times the Sun's radius, is even hotter with surface temperatures of around 37,200 Kelvin. The 2 stars orbit each other every 5.54 Earth years, cocooned in a giant twin-lobed cloud of gas and dust known as the Homunculus Nebula, a spectacular bipolar emission and reflection nebula. Both stars are now nearing the ends of their lives on the main sequence and are expected to go supernova in an astronomically short space of time. When it does go supernova, Eta Carina will become clearly visible in daylight and may even become brighter than the Moon for months on end. This year's second major meteor shower, the Leonids, will peak on April the 22nd and 23rd. The Leonids appear to radiate out from the constellation Lyra, close to the star Vega, one of the brightest stars in the sky this time of year. The source of the shower are particles of dust and debris shed by the long-period comet C-1861 G1 Thatcher. Sky watchers in the northern hemisphere get the best view of the Lyrids. However, those at mid-southern hemisphere latitudes can also see the shower between midnight and dawn. Patient observers will be rewarded by around 18 meteors an hour before dawn in dark sky locations. And now, with a look at what else is happening in the April night skies, we're joined by Jonathan Nally, the editor of Australian Sky and Telescope magazine.
G'day, Stuart. Well, it's April, so yeah, we're now sort of almost in the middle of autumn here in the southern hemisphere, and spring up in the northern hemisphere. And for us here in the south, we're starting to shift from the summer constellations through to the winter ones. So as night falls, you'll be able to see the Milky Way, which is our galaxy seen from the inside. You'll see it stretching right across the sky from the southeast to the northwest during the first half of the night. After sunset, first few hours of evening, that's where you'll find the Milky Way. But as the Earth turns, things in the sky change a bit. So by the early morning hours, instead of the Milky Way going from the southeast to the northwest, it'll now be going from the southwest to the northeast. But you'll still be able to see all of it there, which will be really good. And as the night rolls on after sunset, some of the more famous constellations that we've had around during the southern summer or the northern winter will start to disappear. They'll be dropping out of view below the western horizon. So we're talking about Taurus and Orion. Other ones such as Gemini and Leo are still fairly prominent in the northern sky, as seen from mid-southern or mid-northern latitudes. But give it another month or so and they'll be disappearing below the western horizon as well. So in the early evening during April, we've got the Southern Cross nice and high in the south. The bright star Canopus, which is the brightest star in the constellation Carina, and it's actually the second brightest star in the night sky. It's even higher up, so it's getting towards overhead. You can't miss Canopus. And a little bit further higher up, there's the brightest star in the sky, which is Sirius, which is the brightest star in the constellation Canis Major, the greater dog. In fact, from the latitude of Sydney or any sort of comparable latitude in other countries in the southern hemisphere, Sirius is more or less directly overhead. Now, I mentioned Carina, the constellation Carina. Grab hold of a star map, such as the one you can see in the centre spread of every issue of Australian Sky and Telescope, and use it to find Carina. Very easy to find. Then grab yourself a pair of binoculars and start sweeping through the star fields in this area of the sky, because they'll just take your breath away. It really is amazing. All these clusters of stars, and you can see some nebulosity as well. And if you keep going to the left along the Milky Way, you'll soon come to the Southern Cross. And if your binoculars have got a nice wide field, you should be able to see the whole thing there. And see if you can make out a big, dark nebula that sits just beside the Southern Cross. It's called the coal sack, for obvious reasons, because it's like a big black hole in the middle of the star fields. Then continue further along in the same direction along the Milky Way, and you'll get to the two pointers, which are the stars Alpha and Beta Centauri. Famous pair of stars, and they're called the two pointers because they point the way to the Southern Cross, basically. They're quite bright and prominent, quite close together, and you can use them to just point along. You go along the same direction they're pointing, and you get to the Southern Cross. So if you have trouble finding the cross, just go to the two pointers first.
Yeah, when people get the Southern Cross and False Cross mixed up, the pointers are the way to differentiate between the pair.
That's right. Yeah, the False Cross, it too is a crucifix or kite sort of shape, bigger than the Southern Cross, but that's why people actually get the two confused, the real Southern Cross and this false cross, because when they go outside to see they're trying to find the Southern Cross for the first time, they expect it to be really big, really quite big, but it's actually really small. It's the smallest constellation in the sky. Yeah. So they see this other one nearby, this sort of collection of 5 stars, and think, oh, that must be the Southern Cross. But no, the smaller one is, and the two pointers point towards it. So that's the stars and the constellations and things. So let's talk about the planets. Venus can be seen in the west after sunset. You can't miss Venus. You can never miss Venus. You can never mistake it for anything else because it's so big and bright. But over the coming weeks, it's going to be dropping closer and closer down towards the horizon before disappearing from view into the glare of the sun in the early part of May. So if you've got nice, clear skies in the evening out to the west, that big bright light you see over there will be Venus. The rest of the naked eye planets are actually early morning affairs at the moment, with Jupiter rising over the eastern horizon about 1 o'clock in the morning at the beginning of April, and Saturn and Mars come up together about 45 minutes later. Saturn and Mars, they appear quite close together at the start of the month, but you'll see them start to drift apart as the month goes on. The other naked eye planet, Mercury, that'll be rising also in the early morning hours, about 5 a.m. at the beginning of April, probably an hour or so before the dawn light starts to come up. But as the days go on during the month, you'll see Mercury also, like Venus in the evening, Mercury will be dropping down towards the eastern horizon as it's going along in its orbit, and it will be lost in the dawn glare of the sun by the last week of April. Finally, there's a couple of interesting groupings to watch for between the planets and the moon. The first will be in the early morning hours of April the 15th. If you go out after midnight, you'll see the moon really close to Jupiter. You'll see the moon there, and there'll be a bright star-like looking thing nearby. That's actually the planet Jupiter, okay? The following night, and I mentioned that Jupiter's coming up over the horizon, followed by Saturn and Mars not too much later. Well, the following night, April 16, you'll see Jupiter, Saturn, the moon, and Mars will be almost all in a straight line. It should be really specky to see. You've got Jupiter, big, bright, whitish sort of light. Saturn, a little bit fainter than Jupiter and with a yellowish sort of tinge. Then the moon, and then Mars, which is smaller than the other ones, but a really ruddy, orangey, reddish sort of colour. So it should be a beautiful contrast and a lovely sight to see. These groupings, incidentally, don't mean anything scientifically. They're just line-of-sight effects, but they are very, very pretty to see.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from SpaceTimeWithStuartGary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through SpaceTimeWithStuartGary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.